Hi, this is Kaz and I'm here with a measurement word problem that I've taken from the White Rose Home Learning Resources. This is from a Year 8 resource, and so on the right hand side they've indicated that we might want to use a bar model approach, but if you've not been using the White Rose scheme of work and you're not familiar with bar modelling, then you might choose to take an algebraic approach instead. So I am going to talk it through with using both of these methods side by side, and hopefully you can see that the steps are the same, but it's just the representation, the way we think about it, the way we show it is different. So in a bar model approach, it's very, very visual, whereas an algebraic method, it's a lot more abstract. We start using letters to represent what we don't know. So if we look at the question, we've actually got two variables that we are working with. We've got the weight of a bucket, and I've got the weight of the water inside the bucket. So using a bar model, I would represent the weight of both of them together using these bars. Okay. Now I am told that the weight of the bucket is 0.7, so I'm going to add that into the diagram. Notice how I've actually changed units. In the question we've got kilograms and we've got grams. You need to work in the same unit. I'm going for working kilograms, but if you worked in grams, that's also no problem. And the weight of the water I don't yet know. Okay, so this is my unknown. I'll colour it in blue. That's what I'm trying to find out to help me solve that problem. Algebraically, and if I'm using the algebraic method, I'm going to start using letters to stand for something I don't know. And I'm going to use W to stand for the weight of the water. Let's see if I can add some more information to my bar model. I've been told that when half full of water, the bucket weighs 3.2. So I'm going to draw in that bar, show me that the weight of the bucket and half of the water is equal to 3.2. If I'm working in an algebraic method, then I'm also going to put that into an expression. So I'm going to say that I know that 0.7 and half the weight of the water is equal to 3.2. So if I've got the same information, I just have them in different representations. One's a very visual, one's slightly more abstract. Let's see if I can solve it using what I've got. So solving a bar model, looking at the diagram, I know that this extends to halfway through the weight of the water. So from the diagram, I know that the difference between the bucket and the bucket plus the weight must be 2.5. And as that's half of the water, the other side must also be 2.5. Algebraically, I start looking to solve this equation. I can subtract 0.7 from both sides, and I know that half of the water is equal to 2.5. From that, I can tell that the whole water must be 5. So going back to the original question, work out the mass of the bucket when it's full of water. It must be weight of the bucket is 7 and the weight of the bucket is 2.5. So my total would be 5.7, and I've been working kilograms, 5.7 kilograms. I hope that shows that actually two very, very different methods to use it, but actually the individual steps are pretty much identical. Hope that helps. See you later.